Okay students, up to the last lecture we have studied up to question number 6. Today we are going to start the question number 7. Read the instructions of the question carefully. Show that following functions have continuous extension to the point where f of x is not defined. Also find the extension. Means we have to find, just look at this function, f of x is equal to 1 minus cos 2x upon sin x for x is not equal to 0. It means where f of x is not defined, for x is equal to 0, f of x is not defined. Means we have to find that extension. Find the extension means we have to find the value of the function where the function becomes continuous. The following functions have continuous extension, means we have to find that value where the function becomes continuous for the given point against it. Means for x is equal to 0 here. Now we'll see first example for this function. Here for the function, for given function f of x, f of 0 is not defined, and as f of 0 is not defined, we cannot state the continuity of the function, or we cannot discuss the continuity of the function. Now we are going to find the suitable value of f of 0 where the function becomes continuous. For that we have to find the limit of this function. Means limit of f of x as x tends to 0 is equal to limit of 1 minus cos 2x divided by sin x as x tends to 0. Now remember the formula 1 minus cos 2x. This is limit of 2 sin square x upon sin x. 1 minus cos 2x is nothing but 2 sin square x as x tends to 0. Now we know that as x tends to 0, x is not equal to 0, and if x is not 0, sin x is also not equal to 0. Means here sin x can be cancelled, and we have this is equal to limit of 2 sin x as x tends to 0. Now put this value, it is 2 into sin 0, and we know that sin 0 is 0, it means 0. Hence we can say that if you write this is the limit, we can say that this is limit of f of x as x tends to 0 is 0. Hence we can say that if we define f of 0 as a 0, then we can say that that function is continuous at x is equal to 0. Therefore we can say that if we define f of x, f of 0 is equal to 0, then given function is continuous at x is equal to 0. It means our extension is f of 0 is equal to 0. We can redefine that function f of x is equal to 1 minus cos 2x upon sin x for x is not equal to 0 is equal to 0. We can write it as is equal to 0 for x is equal to 0 here. Look at this. We can write this function like this. Now second question, f of x is equal to 3 sin square x plus 2 cos x into 1 minus cos 2x upon 2 into bracket 1 minus cos square x for x is not equal to 0. Again here for the function, f of x, f of 0 is not defined. Therefore, to find its extension, we are going to find limit of the function f of x as x tends to 0 is equal to limit of This is 3 sine square x plus 2 cos x into 1 minus cos 2x divided by 2 into 1 minus cos square x. As x tends to 0, that is equal to limit of, keep this 3 sine square as it is, 3 sine square x plus 2 cos x into 1 minus cos 2x is nothing but 2 sine square x divided by 2 into 1 minus cos square x is nothing but sine square x as x tends to 0. Now we can take sine square as common from these two terms. Sine square x common, yeah, means we'll get is equal to limit of sine square x common into bracket, here it is 3 is remaining plus 2 into 2, it is 4 cos x divided by this 2 sine square x as x tends to 0. Now again this sine square x and sine square will be cancelled, because we know that as x tends to 0, x is not equal to 0. It means sine x is not 0, and if sine x is not 0, then we can say that sine square x is also not equal to 0. Then we can easily cancel this sine square x and it becomes limit of 3 plus 4 cos x divided by 2 as x tends to 0, because sine square x get cancelled. And now substitute this value here, it is nothing but 3 plus 4 into cos 0 divided by 2. We know that the value of cos 0 is 1, it means it is 3 plus 4, that is 7 by 2. Means we can say that limit of f of x as x tends to 0 is equal to 7 by 2. Hence we can say that if we define f of 0 is equal to 7 by 2, then function becomes f of x becomes continuous at x is equal to 0. Therefore, that function can be written as f of x is equal to 3 sine square x plus 2 cos x into 1 minus cos 2x divided by 2 into bracket 1 minus cos square x for x is not equal to 0 and is equal to 7 by 2 for x is equal to 0. Hence we can say that f of 0 is equal to 7 by 2 is the extension for the given function such that function is continuous at x is equal to 0. Now the third question. Now look at this third question. F of x is equal to x square minus 1 upon x cube plus 1 for x is not equal to minus 1. Means here we can say that for this function, for f of x, f of minus 1 is not defined. And if f of minus 1 is not defined, here we can say that we have to find the extension of this function to make this function as continuous. Means we are going to find limit of f of x as x tends to minus 1. That is equal to limit of x square minus 1 divided by x cube plus 1 as x tends to minus 1 is equal to limit of, factorize it. Now x square minus 1 has factors using a square minus b square, that is x minus 1 into x plus 1, and this x cube plus 1 has factors using the formula a cube plus b cube, that is x plus 1 into second bracket x square minus x plus 1. Use that formula. A cube minus a cube plus b cube is equal to a plus b into second bracket a square minus ab plus b square. Using that formula we have these factors as x tends to minus 1. Now as x tends to minus 1, we can say that x is not equal to minus 1, means x plus 1 is not equal to 0, and if x plus 1 is not 0, we can cancel this factor, and hence this limit of f of x as x tends to minus 1, it becomes limit of x minus 1 upon x square minus x plus 1 as x tends to minus 1. Now substitute these values here. It is nothing but limit of substitute these values directly. Minus 1 upon minus 1 square is plus 1 plus 1 plus 1. Hence it is minus 2 by 3. Means limit of f of x as x tends to minus 1 is minus 2 by 3. Therefore you can say that if we define the extension of the function f of minus 1 is equal to minus 2 by 3, then function becomes, f of x becomes continuous at x is equal to minus 1, and hence we can write the function with the extension that f of x is equal to x square minus 1 upon x cube plus 1 for x is not equal to minus 1 and is equal to minus 2 by 3 for x is equal to minus 1. Hence that function becomes continuous at x is equal to minus 1. This is about the question number 3. Question number 7. All the 3 sub questions we have solved. Now we are going to start question number 8. Read the instructions. Now look at for question number 8. Discuss the continuity of the following functions at the points indicated against them. F of x is equal to root 3 minus tan x upon pi minus 3x for x is not equal to pi by 3 is equal to 3 by 4 for x is equal to pi by 3 at x is equal to pi by 3. Now we are going to discussing the continuity of the function, means we have to check whether the limit of the function and the value of the function are equal or not. For that we are going to find the limit of the function. Limit of f of x as x tends to pi by 3. Now in this example there is no need to find left hand side limit and right hand side limit, because the function is constant for x is less than pi by 3 as well as greater than pi by 3. The value of tan x or x may not be changed for that two values. That's why we are going to find limit of f of x as x tends to pi by 3 direct. Now limit of root 3 minus tan x divided by pi minus 3x as x tends to pi by 3. Now this is example of substitution as x tends to pi by 3 and here it is the term pi minus 3x. We can say that this is the example of substitution. Put pi by 3 minus x is equal to h. If you multiply it by 3, we have pi minus 3x is equal to 3h. If you multiply it by 3, it becomes pi minus 3x is equal to 3h. And from pi by 3 minus x is equal to h, we can say that here 3x, x can be written as x is nothing but equal to pi by 3 minus h, or as x tends to pi by 3, if x tends to pi by 3, if we substitute pi by 3 here, pi by 3 minus pi by 3, it becomes 0. Therefore we can say that h must tends to 0. Once again look at this substitution. As pi by 3 minus x is equal to h, we have pi minus 3x is equal to 3h, and x is equal to pi by 3 minus h, because when x changes its side, then h becomes minus h. Now this limit becomes limit of root 3 minus tan of x is what? Pi by 3 minus h. Pi by 3 minus h divided by this pi minus 3x is nothing but 3h, and when x tends to pi by 3, h tends to 0, means here h tends to 0. Now while solving this example, we have to use the formula tan of a minus b. We know that the value formula tan of a minus b is nothing but tan a minus tan b upon 1 plus tan a into tan b. Therefore, this limit becomes limit of root 3 minus this tan of pi by 3 minus tan h upon 1 plus tan pi by 3 into tan h divided by 3h as it tends to 0. Now substitute the value of tan pi by 3. We know that tan pi by 3 means tan 60 degree, and tan of 60 degree is root 3. Therefore we have, it is limit of root 3 minus tan h divided by 1 plus root 3 tan h divided by 3h as it tends to 0. Now solving it, taking cross multiplication, we have limit of root 3 into 1 is root 3 plus root 3 into root 3 is 3 tan h minus root 3, and minus into minus this plus tan h divided by 3h into bracket 1 plus root 3 tan h as h tends to 0. Now this root 3 and root 3 get cancelled. 3 tan h plus tan h is 4 tan h. We can say that it is limit of 4 tan h upon 3h into bracket 1 plus root 3 tan h as it tends to 0. Now using algebra of limits, we can separate it. It is 4 by 3 into limit of, as we know that the formula tan x upon x as it tends to 0 is 1. Separate this tan h and h, tan h upon h as it tends to 0, and into this limit separate 1 upon 1 plus root 3 tan h. Look at this step as it tends to 0. Why we have separated into two limits? Because we have separate formula for tan h upon h. Limit of tan h upon h is 1. Here it is 4 by 3 into 1 into, substitute the value here, 1 upon 1 plus root 3 into tan of 0, and we know that tan 0 is 0. Therefore it is 1. 1 into 1 means we can say that here limit of, therefore limit of f of x as x tends to pi by 3 is nothing but 4 by 3. Now look at the value given. It is given 3 by 4. But we can say that, but f of pi by 3 is given 3 by 4, means they are not equal. Hence we can say that limit of f of x as x tends to pi by 3 is not equal to f of pi by 3, is not equal to f of pi by 3. Hence we can say that therefore f of x is discontinuous at x is equal to pi by 3. Means first question where the function is given root 3 minus tan x upon pi minus 3x is discontinuous at x is equal to pi by 3 because the limit of the function and value of the function are not equal. Now you take its screenshot. I will prepare for second question. Look at for this second question. F of x is equal to e raised to 1 by x minus 1 divided by e raised to 1 by x plus 1 for x is not equal to 0 is equal to 1 for x is equal to 0 at x is equal to 0. Look at the function e raised to 1 by x. Now we know that as x is not equal to 0 means either x is less than 0 or x is greater than 0. Means x can take its negative value as well as positive value. Then what effects on e raised to 1 by x? When x is very closer to 0, when x is tending to 0 and x is less than 0. At that time, this e raised to 1 by x, it becomes e raised to minus 1 by 0. Means it is e raised to minus infinity, that is 1 upon e raised to infinity, that is 1 upon infinity, and it tends to 0. But when x is tending to 0 means it is very closer to 0 and x is greater than 0 means it is positive. When e raised to 1 by x, it tends to e raised to 1 by 0, it means it tends to e raised to infinity and it tends to infinity. Means look at these two cases. For the function e raised to 1 by x, it will changes for less than 0, it becomes 0, and for greater than 0, it is going to infinity. That's why here if the function is given in this format, then also we are going to find here LHL and RHL, because for both less than 0 and greater than 0 function is going to change. That's why we are going to find first limit of the function as x tends to 0 minus. Now first of all, LHL means limit of f of x as x tends to 0 minus is equal to limit of e raised to 1 by x minus 1 divided by e raised to 1 by x plus 1 as x tends to 0 minus. Now as x tends to 0 minus, let x is equal to 0 minus h, where h is positive. And a very small value means we can write it as limit of e raised to 1 upon 0 minus h minus 1 divided by e raised to 1 upon 0 minus h as plus 1 as h tends to 0 minus is equal to, it becomes 0 minus, it is h tends to 0 means it is limit of e raised to minus 1 by h minus 1 divided by e raised to minus 1 by h as h tends plus 1 as h tends to 0. Now this minus 1 by h, it can be written as, using the laws of indices, it is 1 upon e raised to 1 by h minus 1 divided by this e raised to minus 1 by h. To make it positive, it is 1 upon e raised to 1 by h as plus 1 as h tends to 0. Now if you substitute this value h is equal to 0 here, it is nothing but 1 upon e raised to infinity minus 1 upon 1 by e raised to infinity plus 1. And we know that 1 upon e raised to infinity is nothing but 1 by infinity minus 1 upon 1 by infinity plus 1, that is 0 minus 1 upon 0 plus 1. Hence we can say that limit of f of x as x tends to 0 minus is nothing but equal to minus 1. But look at the function's value, but f of 0 is given 1, means there is no need to find right hand side limit again, means left hand side limit is minus 1 and the value of the function is 1, hence we can say that this function is discontinuous. Therefore we can say that limit of f of x as x tends to 0 minus is not equal to f of 0. Therefore, f of x is discontinuous at x is equal to 0. Now it's a time for a screenshot. Now continuing for question number 3, f of x is equal to 4 raised to x minus 2 raised to x plus 1 divided by 1 minus cos 2x for x is not equal to 0, and the value of the function at x is equal to 0 is given log 2 whole square upon 2, and we are going to discuss the continuity at x is equal to 0. Means now here also we have to find limit of the function to check whether it is equal to value of the function or not, and observing the function, this function is a rational function with it is not a rational function but it is a logarithmic function with a trigonometric function. It is a combination of two functions, and it will never be changed for x is less than 0 and greater than 0. Directly we can find limit of the function as x tends to 0. That's why limit of f of x as x tends to 0 is equal to limit of this 4 raised to x minus 2 raised to x plus 1 divided by 1 minus cos 2x as x tends to 0. That is equal to limit of, now 4 raised to x, it can be written as 2 raised to x whole square, because 2 raised to x into 2 raised to x can be written as 4 raised to x, minus, using the laws of indices, it is nothing but 2 into 2 raised to x plus 1 divided by 1 minus cos 2x. It has a formula 2 into sine square x as x tends to 0. Now this is in the form a square minus 2a plus 1, means we can write it as a minus 1 whole square, means this bracket can be written as limit of 2 raised to x minus 1 whole square divided by 2 into sine square x as x tends to 0. Now to find its limit, we must have to divide its numerator and denominator by x square to convert them into the formulae. Therefore, we know that as x tends to 0, x is not equal to 0, means x square is not equal to 0, and that's why divide its numerator and denominator by x square. We have it is equal to limit of this 2 raised to x minus 1 whole square upon x square divided by 2 into sine square x divided by x square as x tends to 0. Now separate the limit for numerator and denominator. We can take this 1 by 2 outside the limit, or we can write limit of this 2 raised to x minus 1 divided by x whole square as x tends to 0 divided by 2 into limit of this sine x upon x whole square as x tends to 0. Now applying the limit, we can enter in this limit of 2 raised to x minus 1 upon x as x tends to 0 is log 2, means it becomes log 2 whole square upon 2 into 1 whole square. Hence we can say that it is log 2 whole square upon 2. Therefore we can say that limit of f of x as x tends to 0 is equal to log 2 whole square upon 2, but and f of 0 is also given log 2 whole square upon 2. Therefore we can say that limit of f of x as x tends to 0 is equal to f of 0. Hence we can say that f of x is continuous at x is equal to 0. Continuous at x is equal to 0. तो यहाँ पे अपना क्वेश्चन नंबर 8 कंप्लीट होता है. we'll see question number 9 and next questions in the next lecture. Thank you.